our time today by beginning our look at ecological psychology. So ecological psychology, it's a perceptual theory. It's an overarching general approach to perception. And like I said before, it's got nothing to do with the environment, except it has everything to do with the environment. So we are going to start our look at this. We're going to start it off with the backstory as to why ecological psychology was so important. Backstory about psychology and how we tried to fit in with the other sciences, and that led to Helmholtz and others and the theories that they had about perception. It was basically a wrong start. And then ecological psychology came around as a way to try to correct that wrong start. And we're going to take a look at the fundamental aspects of ecological psychology. We're going to make it to texture today, but we're also going to talk about the ambient optic array. We're going to talk about perspective structure and an invariant structure. And then one of my favorite ideas from ecological psychology, mostly because of the terminology, is affordances. So let's get going with the backstory for how ecological psychology became necessary and how it was developed. So basically, if you take a look at the history of science, psychology compared to other sciences is a little baby. Because if you take a look at when physics became like a formal science, it became a formal science in around the 16th and 17th centuries. So we're talking about the 1500s during the scientific revolution. And this is when Copernicus came out with the heliocentric model. Galileo had his work on the telescope. Newton came out with his laws of motion in the late 17th century. So physics has been around for a while and has had success for a while. If you take a look at something like chemistry, chemistry has been around for a very long time. They used to call it alchemy, but now they call it chemistry. But it was really made its way as a distinct science in the 18th century. So we're talking about 1700s. When Lavoisier did his work on conservation of mass. And again, you shifted from alchemy, which was around much longer than that, to a more systematic experimental approach. The last major science that we have, biology, that became an independent science in the 19th century. So we had, things like the idea of the cell, the discovery of the cell. I've lost my notes here. The discovery of the cell, Charles Darwin proposed his theory of evolution in the 1800s. The cell came out in the 1800s. Those were all, and biology was around before that as well, but it just kind of went to a separate science at that time. But psychology came extremely late to the party. So by the time psychology came out of like philosophy and went into the sciences, biology, it came in, again, sorry, I've lost my notes, but it came in as a science in 1879 and 1890. Those were the earliest times with William Wundt in Germany and William James Wilhelm Wundt in Germany and William James in America, who did, who started off psychology as a science. So we were late to the party. And worse than that, psychology was associated with a lot of kind of like mystical practices, right? So with mesmerism, with hypnotism, with spiritualism. So we were almost tainted in the eyes of other sciences before we even began. To kind of adopt a scientific approach. So one of the ways that we compensated for that is we basically said, well, hey, if we are being ostracized by these other sciences because we don't have their sort of background, well, what if we took their background? What if we took some of the ideas that they had? What if basically we made psychology look like the other sciences, and then we would have some respectability? So what psychology did in the early going was they said, hey, you know what? We're going to take concepts that these other sciences are using, and then we'll use them. And once we start using their concepts, they can't object, right? Because if we're using the same concepts that they're using, like mathematics and models and all this kind of ideas, then they can't object because they're using the same thing. So you had people like Helmholtz who made massive contributions to psychology, but naturally used concepts and ideas from physics, especially because he was a physicist and he would use things from biology because he was a physician as well. So kind of almost naturally occurred as well, where scientists who were starting to do psychology said, well, I'm another scientist in another discipline, so I'll bring a lot of those ideas to my application to psychology. So one of the big contributions that Helmholtz made was based on his realization that the image on the retina is ambiguous. So he basically started with the idea that one of the big problems that we need to solve is how do we perceive, for example, the shape of an object? Because the projection of that object on our retina is logically, empirically can be shown to be ambiguous. So what do we kind of mean by this? Well, let's say that you have an object out in the real world and it's a square. It's some sort of quadrilateral, let's say. It's going to produce a certain pattern of light that enters your eye. So we have your eye right there. We have the object in the external world, and light is going to reflect off of that object, and it's going to enter your eye, and it's going to make a particular pattern on your retina. So that light is going to produce a particular pattern on your retina. The challenge is that for that object, you get that pattern of light. But that pattern of light will also be produced by this object. And that same pattern of light will also be produced by this object. And that same pattern of light will also be produced by this object. And that same pattern of light will be produced by an infinite number of possible objects. So the challenge for psychology in perception is, how do we go from an infinite number of possible objects to one object that most oftentimes is actually correct? So how is it that we go from this infinite number of possibilities and we can somehow constrain it down to one possibility, and that possibility is usually correct, and that's why we can navigate in our environment? So one of Helmholtz's ideas, so he made this realization: the retinal image is ambiguous. And one of his ideas was that, well, we're going to use the likelihood principle to constrain those possibilities, to go from an infinite number of possibilities down to one. We're going to use the likelihood principle, which states that when we perceive objects, the object that is most likely to have caused that pattern of stimuli is going to be the one that we perceive. So we're going to get rid of all of these possibilities here by figuring out which one is the most likely. However, the big problem with that, and this is not something that is an intuition, this is something that is actually provable, mathematically provable. When you have infinite numbers of possibilities, the idea of a likelihood makes no sense. The idea of likelihood is actually impossible. Because when you have an infinite number of possibilities, and it's kind of hard for our mind to wrap itself around infinite number of possibilities, when you have infinite possibilities, no possibility is likely. There's a 0% chance that any of them are correct, because you have one possibility divided by a million. See, I can't even do it. By an infinite number of incorrect possibilities, the chances of that one is 0. So you can have all the inferences you want. You can have all the likelihoods you want, and you're going to be able to take that infinite number of possibilities and you're going to be able to reduce it down to infinite. That's the only thing that can happen, and that's mathematically, logically provable. So this idea that the likelihood principle could take us from infinite possible objects based on a single retinal impression that's ambiguous down to the correct perception just cannot be true. It's philosophically, logically impossible to do. And Helmholtz wasn't the only one that was wrestling with this idea of how do we go from an infinite number of possibilities down to one perception that we have. So this is actually something that George Berkeley wrestled with as well. So he was a philosopher back in the 1600s. And he also noticed that we have this kind of ability to perceive objects, but it's ambiguous in terms of what the objects are, and that objects don't change, our perception of objects don't change. He had this whole argument outlined that was very, very close to what Helmholtz was saying. And he suggested that the only way to solve this problem was by resorting to God. And basically, God was the one that reduced the infinite possibilities and gave you that one perception. God was the one that made perception possible, which as a scientist is a horrible theory to have. Not because it doesn't explain anything, but because it explains everything. And that's not what you want with a theory. It's not falsifiable. But anyways, this was what we were dealing with. We were dealing with infinite possibilities going down to one perception. And importantly, that perception was usually correct, which allowed us to move through our environment. However, the reason that this occurred, the reason that we ended up in this predicament of how can we possibly solve this impossible to solve problem. I mean, that was what it eventually came down to. We have a problem that we can solve as a mind. Our mind can solve this problem, but as we set it up, it's impossible to solve. So we have a situation here that was a lot like the train situation, where we have a problem that has a solution, but it's set up in one way here that makes it impossible to solve. So why is this impossible to solve in this way? Well, it's possible to solve because what Helmholtz did was he said, we're going to take physics and we're going to apply physics to this problem. So we're going to take a look at physics and we're going to use the approaches and the ideas of physics to solve this psychological problem. And what physics does is it says, all right, we're going to deal with mathematics. So that's fine. We're going to deal with mathematics. But we need to make the calculations simpler. So what we're going to do is we're going to make some assumptions. So if you've ever taken a physics class, one of the first things that they do is they say, well, let's assume that there's no friction in this particular example. We're going to measure the speed at which a ball rolls down an incline, and we're going to say that there's no friction. Not because there's no friction in the real world, but because friction makes the calculation massively more difficult. They're going to say we have this object and let's reduce it to a center of mass, right? They're going to say we have a plane, let's reduce it to a mathematical plane. You know, we have this ball, let's reduce it to a mathematical sphere, and then we can start doing our calculations on it. So what Helmholtz basically did is he said, all right, we have this world that we're perceiving. Let's reduce it to mathematical object. Let's reduce it to mathematically determined shapes in a frictionless, environment, in an environment where we have, or a situation where we've made certain assumptions, right? So we have these mathematical abstractions that we're trying to perceive. That's what Helmholtz did, again, because he came from physics. That led to massive, massive problems. So what is a possible solution? Well, one solution that came from James Jerome Gibson. So James Jerome Gibson, he was a psychologist, and he's one of these super interesting cases in psychology. Because if you look him up on Google, Google recognizes him as one of the most important perceptual scientists in the history of psychology. So he is one of the giants in visual perception in psychology. However, there are some textbooks where this comes out, and there's other textbooks where it doesn't. And your textbook, unfortunately, is one of the ones where it doesn't. So I checked in the reference section of our textbook, and it's got one book of James Gibson that is referenced. And when I looked for that reference in the chapter on perception, I couldn't find it. I couldn't find what they were referring to in the chapter on perception. And this is one of the major contributors to our knowledge of visual perception. So he's a very interesting case of somebody who made massive contributions and yet at the same time is oftentimes ignored. So that is one mystery that some people have tried to solve. One other thing about him though, so just kind of full disclosure, the reason I know a lot about Gibson and ecological psychology is because my PhD supervisor taught me a lot about ecological psychology. And that's because his PhD supervisor taught him a lot about ecological psychology. And that's because that person was Gibson. So my supervisor was supervised by Gibson. So I'm sort of a PhD grandchild of Gibson, if you want to call it that. But he proposed this idea, this ecological psychology idea that we're going to introduce here, and then we'll save a lot of the nitty-gritty for it. But he basically said, all right, let's take a look at the starting point of what perception is all about, right? What do we need perception? Why can we, as entities that exist, why can we perceive? What is it doing for us? What is the function of perception? And he said, well, the function of it, the starting point, what we're going to start our theory with is that the goal of perception is the guidance of adaptive action. So the goal of perception is to be able to act properly and beneficially in your world. The goal of perception is not mental inferences from physical sensations. So remember how we defined perception as the internal experience that arose from external stimulation of your senses? That's a definition of perception. That's not the point. That's not why we have perception. We don't have perception so we can have this fun little movie going on in our minds. We have perception so we can move through the world and we can act on the world in adaptive ways. So he said, all right, let's start with that as a starting point. What does that do for our theories of perception? Well, he said, all right, in this case, perception is, if we're acting on the environment, then perception is going to be direct. Perception is going to be non-inferential. And perception is going to be information that is gathered from the environment. So we're going to talk about each of those in a little bit in just a moment. So that is where he ended up. But before we get to that, let's see how that flies against, before we go into the nitty-gritty of this, let's see how that flies against what was the widely accepted framework, which was physics. So again, physics, Helmholtz came from physics. Psychology said, hey, let's use some of the tools that physics is using and we'll apply it to perception. So this was the widely accepted framework. Everybody was doing work on Helmholtz prior to Gibson coming up. And the widely accepted framework for physics is that you have bodies in space. So once again, we have this idea of we're trying to understand the laws of motion. When you're trying to understand the laws of motion, you take a look at an isolated body in space. How does it move? How does it fall? You take a look at one body interacting with another body in space. You know, how do they interact? So that was what they brought from physics. And what we perceive are these objects in space. And what that means is that the approach that we're going to use is an abstract approach. It's a mathematical approach. We're going to say we're going to mathematically define those bodies. We're going to mathematically define the spaces. And also, it's very passive. So nothing in physics requires an active user, right? None of the physical laws require you to actually be active on it. You don't have to do anything for gravity to work on you, for example. Gravity is working on you whether you are doing anything or not. It's just passive, unfeeling, unintentional. It is what it is. It does not require an active participant. That was the framework that they had. He came up with a different framework. And he said, all right, let's stop with this passive idea. Let's stop with this abstract idea. what can we start with? What starting point can we use that might be better? That might be a better place to start. He said, all right, we're going to do the ecological framework. And instead of bodies in space, what we're actually perceiving, we don't perceive bodies in space. What we're actually perceiving is we're perceiving mediums, we're perceiving substances, and we're perceiving surfaces. So what is a medium? A medium are things that transmit objects, things that transmit light. So things like air is a medium, things like water is a medium. And then we have substances, and substances are basically things in our environment that have extent. So they have a width to them, they have a depth to them, they have a length to them. So this desk is a substance, this computer is a substance, I'm a substance, right? So we have substances, we're in a medium, I'm in the air, or I'm in the water. I'm never not in the air, never not in the water, right? And then we also have surfaces. And surfaces are where your medium and your substance interact, right? So the surface of my body, my skin, this is where the substance of my body meets the medium of the air, right? The surface of this table, this is where the table meets the medium of the air. If I put my hands on it, then the surface of this table interacts with the surface of my fingertips, right? So we have surfaces, we have substances, and we have a medium. What we perceive are not objects in space, right? Because you can notice we're not starting with objects. We're not starting with bodies in space. We're starting with medium, surfaces, and substances. So what we perceive are surfaces in a medium. So we perceive a desk in the air. We perceive a fish in the water. We perceive these surfaces when they interact with mediums. And rather than an abstract mathematical approach, what we do is we say, all right, this isn't abstract, this isn't mathematical. These are organisms in an environment. And this is where the importance of the environment comes. So this is one of the big things that Gibson brought. He said, look, we are organisms in an environment. You can't have perception without an organism. If there is nothing, nobody there to perceive, perception doesn't exist. You can't have perception without an environment. We have never been in a situation where you are not where you are and you are not somewhere, right? So think about your entire life. Your entire life, you have been in an environment. At no point in your existence have you been not in an environment. It's something that doesn't even make sense to talk about. When was the last time you were not somewhere? You're always somewhere, right? Might not want to be there, but you're always somewhere. So we have these organisms, we have an environment, you need both of them. And this is one of the places where that idea of embedded cognition comes from. Because perception is not just an organism thing, and it's not just an environment thing. It's the organism and the environment together that make perception perception. And then the last thing that we have is, because we have an organism in an environment, organisms do stuff, right? Organisms do things, they interact with their environment, they are active. And that activity is an important part of what perception is all about. It's an important starting building block to understand perception. So let's take a look. We're going to end today with a look at the medium, the substance, and the surface. And then next time we'll pick up with the rest, the other kind of massive building blocks. But one thing that once you start to think about not bodies in space, not abstract mathematical entities, but you think about actual substances that exist in the world interacting with an actual medium, one of the first things that pops out is that we have things that we perceive, and these things have texture. So how does this help? How does this help solve our issue of going from an infinite number of possibilities down to that one possibility? Well, let's take a look. So let's say that you have a child, they're looking out their window. And what they see out their window is this, right? So they see this idealized mathematical plane, right? So this is an idealized mathematical plane. This is what they're seeing when they see outside their window. And this is a top-down view. So we have the child looking through the window, And the question that we have to answer as psychologists understanding perception, and the question that this child needs to answer doing perception, is what is out there? What is beyond that window? And one possibility that would lead to this pattern on your retina, one possibility is this. That we have another building with an idealized surface, and that building is parallel to the window, and that is, what he's looking at. He's looking at a wall that's parallel to the window. However, that pattern that is going through that window is 100% consistent with this as well. This could be the situation, because that idealized surface tilted would still produce that pattern, right? So if you take a look at the pattern from the eye, you have your eye right here, let's say it was at the center, and you go through the window and you encounter the brick color, right? It's in the window. You go through this side, you encounter the brick color, it's in the window. The entire projection of that image would be that brick color for the window. So it's 100% compatible with that actual external reality. And it's also 100% compatible with this external reality. So when Helmholtz said, let's start with idealized surfaces, he invented the problem where it was like, well, is that real surface this? Given that projection, is the surface this? Is the surface this? Is the surface this? Or is it the infinite number of different angles that it could possibly be, and the infinite number of different tilts that it could possibly be? How could we possibly solve that perception of that idealized surface? And the answer is we can't. It's not possible. However, Gibson said, well, wait. Maybe we're doing this all wrong, because physics says that we live in a world like that left-hand window. But when you take a look at the actual world, it looks more like that right-hand, where we have non-idealized surfaces, and we have surfaces that are filled with texture. And we're going to see next time exactly what that buys us and exactly how that helps us solve our problem. But we're going to end today with the idea that once you get out of the conceptual ideas of physics, which worked wonderfully in physics, like I'm not harping on physics whatsoever. I realize, I'm wearing physics and using physics, to do this class. I'm a huge fan of physics, but it wasn't the right starting point for psychology. Our mind is not the universe, and we needed different tools. And one of the things that James Gibson said is that, yes, we need different tools. And when you think about the real world, the world that we actually live in, texture is everywhere. The environment that we actually live in has texture everywhere. And once you realize that, you will become much more aware of the texture out in the world. So we have texture when you take a look at the bark of a tree. We have texture when you take a look at textiles like towels and your clothing has texture. We got texture in the tiles that we walk on. This floor has texture. The ceiling has texture. Cloth has texture. Wood has texture. Fur has texture. All of these things have texture. And we're going to see how that texture is going to be used to help us perceive things. So for example, a field of rocks has texture, but it's not random, right? I mean, the rocks are randomly sized, right? So if you pick up one rock and you pick up another rock, they're not going to be the same size. It's not like tiles on a floor that's man-made. In the real world, you pick up one rock, you pick up a second rock, they're not going to be the same size. However, on average, the rocks in one area of this field are going to be the same size as the rocks in another area of the field. So they're random, but they're stochastically random, which means there's a structure to their randomness. And you get the same thing with a field of sunflower. And what this means is that when we're looking at how to answer this idea of perception, we're going to introduce this idea of texture, which means that we have a lot more information to go off of. Because if you take a look at that area of this field, and you take a look at that area of this field, those two areas, the information in those two areas is extremely different. But if you start to idealize the surface, and you say, all right, well, maybe we're dealing with a surface where we've smoothed over the edges, and we're dealing with a surface that isn't an actual real environmental surface, but we're going to smooth over the edges, and we're going to make it a mathematical abstraction. Well, then all of a sudden your sunflowers are gone, and the perception of those sunflowers, impossible. Not because they're not there, not because we can't perceive them, but because we're starting with the wrong ideas. So that's what we're going to delve into next time. How can we use this texture? How can we use this approach to help us solve some of these problems that seemed unsolvable in perception psychology? But as far as today, that is it for what I wanted to cover. So start thinking about, the fact that we're an active perceiver in an environment. And then we are going to take a look at the implications of that and how it solves perception next time. But as for today, we are done.